Hi there, welcome to the Pluggable Authentication Framework talk. We'll start with a little about myself. I am John Lightsey. At cPanel I'm called JD because there are so many Johns. I've been a Linux system administrator since the year 2000. I've been programming Perl for just about as long. Since 2005 I've been a member of the Debian project, which of course requires me to tell you that the Debian logo comes with no warranty express or implied, and if you go blind looking at it, that's your problem. I've been a member of the cPanel development team since 2007, and I've been the lead developer on the Pluggable Authentication Framework project since December of 2009. So that's me in a nutshell. Before we get into the meat of the talk, I need to start off with a couple disclaimers. What we're talking about here today is future functionality. It's not fully implemented, and basically the design may change substantially before it actually reaches you and your servers. We have time frames projected for when the Pluggable Authentication Framework is going to be completed. Those may change in the future, and they may change because of feedback that you provide to us. We want to get it right the first time so we don't have to talk about Pluggable Authentication Framework 2.0 in 2011. So let's start with a broad overview of what we're going to be talking about. This is the cPanel Automation Bootcamp, and if you've ever been to boot camp, you know that the Army teaches in a certain fashion. They follow the crawl, walk, run model, and we're going to follow that today. So the crawl is looking at authentication in the present system, how it works, what its features are, and what the quirks of how it works are. Then we're going to start walking and talk about the Pluggable Authentication Framework in a very broad way, discussing the overall design of it and the benefits of that overall design. Then we're going to start running and talking about how you can hook into this new framework. Then we're going to talk about a few side projects that have been joined up with the Pluggable Authentication project. They aren't really related directly to that project, but they're being solved in that same project. When you're authenticating into a system, you are basically providing a username and password, and you're trying to get access to an account on the system. And there are certain account types. We're going to start off with two primary types. The first is a system account. This is a user that has an entry in the etc password file. It has its own user ID. You'd see these on all Linux and Unix systems. The second primary type is a virtual account. These are really a feature of different services. For example, you might have a mail virtual user. And we also have secondary types on cPanel and WHM systems that you wouldn't see on a normal Unix and Linux system because these are specific to our product. The first is a cPanel user, which is basically a system account with some extra metadata attached to it. The real defining feature of a cPanel account is that it has a var cPanel users username file, a CP users file as we like to call it. Obviously there's other metadata, but in terms of authentication, that's the primary piece that we're concerned with. The other secondary type are WHM accounts. These are kind of special, and there are different types of WHM accounts. First, you have a normal reseller, which is a cPanel account that's been given reseller privileges in the WHM reseller interface. You also have the possibility of hand-configured resellers. These are basically system accounts that are not cPanel accounts. In other words, they have no CP users file, but they've been added to the var cPanel resellers file. This is a common way of, for example, disabling root access and having some other account on the system sit in that position instead. And of course, you have root. Root is a special WHM account. It's the default reseller, but at the same time, it's not listed in the var cPanel resellers file. It has no CP users file, so it has kind of a special position in the system. And in a broad sense, we have system accounts. Those are a superset of the secondary accounts, and within the secondary accounts, it's divided up further into the various account types. Virtual accounts, I touched on those at the beginning, but haven't mentioned them here. Virtual accounts really are a feature of the various services, and they manage their own virtual accounts and the features of those virtual accounts. I have a matrix that shows the different account types that are allowed in the different services. Some different quirks to notice here. If you look at mail services, you'll see that IMAP POP SMTP, you can log in with a system account, but you can't If you were to go to webmail directly, you can't log in with a system account. You need to be logging in with a cPanel account, right? Another quirk of this setup is front page and MySQL. If you look at those, they only support virtual accounts, right? You might expect that they would support system accounts, but the reality is they don't. What we tend to do is we set up a virtual account that exactly looks like the system account, and whenever you change your password, we change the virtual account's password also. This kind of keeps those in sync where otherwise, they would be totally out of sync. This may change in the future, particularly with MySQL, with the DB user changes that are coming into cPanel. This slide also mentions Telnet. Telnet looks exactly like SSH and SFTP. You have system, cPanel, WHM, and no virtual accounts. Really, it's 2010. If you have Telnet turned on your servers, please turn it off. Tell your users to stop using that. So now let's talk about the broad organization of the current system. Really, when you look at each individual service in the current authentication scheme, they fit into four different design patterns. The first design pattern that you really see in services is where it has virtually no integration with our authentication code. Some of these services will hook into PAM, and we can hook in our code just a tiny bit through the interfaces that PAM provides. Some examples of this minimal integration model are SSH and SFTP, ProFTPD, MySQL, front page. These all are not very well integrated into the present system, and they pretty much have their own standalone password files. We can add users through those files, but we can't really find out exactly when an authentication attempt is taking place. On the opposite end, you have a design pattern where we provide all of the code from end to end. Basically, these are services that cPanel provides the whole shebang. We can hook in at any level of authentication and find out exactly what's going on at any given moment when an authentication attempt is taking place. These really are in two main groups. First, you have the services that are managed by cpservd. That's our sort of super server that manages webmail, cPanel, WHM. And then WebDAV is kind of an exception because it's its own service, although at the same time we provide all of the code that goes with WebDAV. Some of it's cPan modules, but realistically speaking, we control those as well. You also have another design pattern where a service will talk to cPanel code either over a socket or through an authentication binary that it will run each time an authentication attempt takes place. Right now, we only have one really good example of this, and it's PureFTPD. If you look in the startup scripts for PureFTPD, they run a cPanel-provided PureAuthD server. It opens a socket, PureFTPD talks with it. Sort of a variation on this is the last design model where you have a service, it has its own authentication server, and that authentication server talks to cPanel code. The mail servers actually follow this design pattern. Dovecot has its own authentication server, and Courier has its own. Exum does not follow this pattern, but we've hooked it into either Dovecot or Courier, depending on how your system is set up. So that's the overall design. Now let's talk about some of the quirks of the current system. One of the really quirky areas in the present system is virtual accounts. I mentioned these a little earlier. Basically, the main problem with virtual accounts is that they're not really a first-class concept on a cPanel and WHM system. Each virtual account is sort of tied to the service, and there is no unified virtual account concept. This is kind of shown in the interfaces. When you go into your cPanel interface and you go to, let's say, create an add-on domain, it prompts you to create a virtual FTP account. It does not prompt you to create a virtual WebDAV account. It does not prompt you to create a virtual IMAP account. Likewise, if you go to the IMAP interface, create a virtual IMAP account, it does not prompt you for the other ones. They are not tied together in any meaningful way under the present system. There's also a very noticeable quirk in the way virtual accounts are specified. In some instances, when you go to a particular IP address, mainly a dedicated IP address, and you log in using just the username there instead of username at domain like you would normally specify a virtual account, it will actually first try to authenticate it as a virtual account, and then fall back on system accounts. In other places, if you were to do this, it would first try the system account and not try the virtual accounts at all. It's a little quirky under the existing implementation. And the quirks go beyond the client-side perspective of how virtual accounts work. It's not just that the interfaces are mixed up or that the ways you log in are confusing. On the back end, the actual code that implements the virtual accounts is scattered all over the place. Because each service is managing its own virtual accounts, the actual password hashes are stored in a variety of different places. They're not really well centralized. So another quirky area is override logins. If you don't know what these are, an example is when you go to the cPanel interface, you log in as a cPanel user using the root password, or if you were to go to the WebMail interface, you log in as a WebMail virtual account using the cPanel password. The actual rules that govern where and when you can use these sorts of override logins are pretty confusing. It really just depends on the service. Some services are completely unsupported. In some situations, a reseller with all privileges is treated identically as the root user itself. In other situations, root is given special treatment that a reseller with all privileges isn't. The settings that control override logins are a little scattered at present. The main setting, as far as these go, is in the tweak settings interface, but you can also control override logins in the exim configuration interface. And some of the services that offer override logins aren't really configurable. Access controls are another quirky area on cPanel and WHM systems. When talking about access controls, the main one that we have is CP-Hulk. CP-Hulk sort of sits in a privileged area when an authentication takes place. It can look at an authentication attempt before the credentials are validated and look at it again afterwards. And if there's a brute force taking place, it can block it at either point in the process. The only problems with CP-Hulk are that some services don't really work very well with it. For instance, Courier does not tell CP-Hulk what IP address was attempting to perform authentication. This means if somebody is trying to brute force your mail system, the only thing CP-Hulk can do is lock out the accounts that they're trying to log into. It can't actually block the IP address that's making the attempts. ProFTPD has no CP-Hulk integration at present. So if you want to prevent someone from brute forcing your FTP services, you have to choose pure FTPD. You have no other option. Mailman, MySQL, Postgres, these are only covered by CP-Hulk if you limit the access to them to CP-Servd. So for instance, you can get MySQL protection if you only allow them to go through PHPMyAdmin under CP-Servd. If you provide a public-facing TCP socket for MySQL, CP-Hulk isn't going to know anything at all about people trying to brute force connections over that socket. And CP-Hulk is a good system, but what if you want to do your own? How do you customize CP-Hulk? You could conceivably parse log files, figure out who's trying to brute the system and block it in the same sort of fashion as fail2ban. This isn't as good as CP-Hulk, and it doesn't sit in that nice spot that CP-Hulk is presently at. So there's really no way at present to insert your own code into that area. Logging is also another quirky area within the present system. Logging is kind of scattered. This isn't really a new problem to cPanel. If you've been using Linux and Unix, you know that there are various log files that are supposed to be definitive for authentication, and in fact, they don't include all the different authentication attempts. There's a chart that gets passed around in cPanel. It has a huge list of all the log files and where they are and what they contain. And really, it just kind of reflects the overall problem. It's very difficult to know where to look for authentication and logging. Some services are going to log success, some are going to log failure, some are going to log both. A good example of this, if you look in user local cPanel logs, login log, that's the CP-Servd authentication log, it only tells you about failures. It does not tell you who logged in successfully. You have to kind of figure that out on your own using the access log instead. Some services are going to tell you which usernames were attempted. Some of them are going to tell you which remote IP address the failed login was coming from. It just depends on the particular service. Really, we should be able to do a little bit better and get this stuff standardized in some nice ways. Another quirk of the present system is password hashes. This may sound like an odd thing to have as a quirk, but the reality is all of our different authentication services are working with salted hashed passwords stored in password files. This makes it very difficult for us to support HTTP digest authentication, which requires the passwords to be stored in a different hashing format. Also, the present system doesn't trust sessions very much. We generate sessions, we use sessions, but ultimately we don't trust the information that's in that session file very much. And in many places where we could use that session data, we actually end up revalidating the passwords over again, which is obviously much more expensive and decreases overall performance. The use of password hashes also means that the system must have those password hashes on it. If you want to centralize on LDAP or Radius and keep all the hash passwords on a different machine, it's not going to work with our present system. They have to be on, those hash passwords need to be on the system, and they need to be in multiple spots on the system. Another quirky area with the present authentication system is how it affects quality assurance and development. All of the existing authentication implementations are pretty much independent. They share some common modules on the back end, but at their core, they are all fairly independent of each other. This makes it very, very difficult for our quality assurance department to test every form of authentication on the cPanel and WHM system. It also makes it nearly impossible for a customer to authenticate connections in a fashion that's identical to what we're doing. You know, you basically have to go and rebuild all of that authentication code from scratch into your custom service. So that basically wraps up the quirks section of the talk. So it may sound like I'm just giving a litany of different failures of the present implementation. The reality is we have some great successes. You know, there are a lot of aspects of the present authentication system that are worth keeping and worth bearing in mind. In my mind, the most important is cpservd. When you look at other products that provide the cPanel and WHM style of privileged services over HTTP, some of them try to use Apache and SUEXEC to accomplish that. And really the security implications of providing those type of services over the normal web server are just a little frightening. It's better that we have our own server that's well audited and very focused on those particular services. We also have two clusters of services right now that have very, very good authentication integration with our cPanel code. Those are your mail services and the cpservd services. Built on top of cpservd, we also have some unique and worthwhile authentication protections that you can enable to make authentication much more secure. The first is security tokens. This is going to protect you from cross-site request forgery and a problem that's kind of unique to our type of setup where someone could potentially steal the cookies using the same domain on a different port. You can also disable HTTP auth entirely. This is a good feature to enable so that, well, the problem with the HTTP protocol is that HTTP authentication provides no way of actually logging out. You have to sort of trick the browser into logging out, and it doesn't work on all browsers. It's a good idea to turn it off, and besides the security aside from the security implications, you also get a much nicer login form when you do this. cphulk, I've already mentioned. It's a great system. It does have some little quirks that we hope to get ironed out in the new system. You have the older cookie checks and the referrer checks. I would use security tokens instead. They kind of cover the same ground. You can force cPanel and WHM to require SSL for anyone who's logging in now. In the past, you had to kind of manually do this, and it was a little tricky to accomplish. You can also control the SSL crypto schemes that are used on pretty much any service that does authentication now. PCI compliance requires you to lock them down a certain way, and to be honest, it's a good idea whether or not you're shooting for PCI compliance. Another really great feature of the present system is the CheckServd auth integration. With check servd in the past, it would check that each process is actually running. Nowadays, services that are well integrated with the existing auth system, check servd will perform a test login in addition to verifying that the server processes are running. So you get a lot more scope to how much check servd is verifying your services really are up. At the very least, somebody can log into them. So that kind of covers the present system and our crawl portion of the talk, and now we're getting on to walking. We're going to talk about the new pluggable authentication framework system in an overall design way. And to really understand the new system, you have to kind of look at mail services and how they presently work. Dovecot, you have IMAP POP SMTP. They talk to a Dovecot auth server. That talks to a check password binary. The check password is an interface that QML introduced. And the check password binary is supplied by us, and it runs cPanel authentication code. Courier is pretty much identical. IMAP POP SMTP. They talk to Courier auth daemon, and that one talks to an authprog binary, which is a standard that Courier introduced. And the authprog is provided by us. It runs cPanel code. So central to the pluggable authentication framework as we're rolling it out is a central cPanel authentication server. What's going to happen here is that this will replace either Courier auth daemon or Dovecot auth, and mail services will talk to it directly. But beyond that, we're going to have cpservd, webdev, FTP, basically any service that's doing authentication that we can really control. We're going to have it talking to our central authentication server directly, and it'll be one single auth server on the system. The real benefits of using the single auth server strategy are that we can cache pretty much everything. We have one process running at a really nice spot where we don't need to open the etc password file or the etc shadow file every time and parse it. We can open and read it once, keep it in memory, stat the file to make sure it didn't change each time an authentication attempt takes place. Likewise, virtual accounts, once a virtual account has signed in, if it comes back again or they go to a different interface, those credentials will be cached, at least to a certain extent. In terms of memory impact, we're hoping that this change will either be neutral or positive. For one thing, we're replacing either Dovecot or Courier auth that's currently running on your system with our own auth server. So hopefully those will balance out. And even if they don't, by moving a lot of the authentication logic into this central authentication server, we should be able to lighten the memory requirements of, for instance, cpservd or cpdavd or some of these other services that are currently carrying around their own authentication code. In terms of performance, the new system should be quite a bit better. It sounds like it should be very expensive to open a socket, send an authentication request to a central server, get a response back, and act upon that response. But the reality is, each time you authenticate into a different service on cPanel, we have to check the etc user domains file, the cp users file, quota files, the password file, the shadow file. All of that is a whole lot of churn that central authentication server is going to get rid of you through its improved caching. So most of the features I've described of this new central auth server, we could already gain by simply taking other services and making them talk to Dovecot auth or Courier auth as we do with Exum already. So why is it that we didn't just standardize on Dovecot or Courier and avoid the expense of writing our own authentication server? Well, the first reason is that we want the auth server to be able to return service-specific data. For instance, your FTP quota is very different than your IMAP quota. They're both a quota, but they have very different meanings and different values. So we want it to know the difference between the different services. We also want an authentication server that can speak more than one protocol. Both Dovecot auth and Courier auth have a single protocol they use to talk to authenticating services. So if, for instance, we were to standardize on Dovecot auth and you wanted to run Courier still, we have to shim in some way for Courier to talk to Dovecot's authentication server. It's a little more complicated than it needs to be, and by speaking multiple protocols, we can have it speak Courier to Courier and Dovecot to Dovecot. This central authentication server is going to automatically fix some of the long-standing problems, some of the ones that I just discussed. For one thing, overrides are no longer going to be a problem in terms of what sort of override behavior will I get here, what sort of override behavior will I get here. The central auth server is going to handle all the overrides, and so it becomes more a matter of which quirks of the existing system do we want to replicate and continue to be there. Overrides are going to be synchronized by default. CP Hulk, also, with the present system, each authenticating service kind of has to manage its own CP Hulk checks. This is why some of them aren't very well integrated with it. With the new central auth server concept, the central auth server is going to do CP Hulk and whatever else you want in that same spot. Sessions are also going to be much nicer with the central auth server because it will generate and manage the sessions. A good example of the importance of this is that when you log into webmail now, you provide your password to CPServD. Your CPServD provides that password to the PHP application that's doing webmail. That PHP application provides the password to IMAP and SMTP to actually interact with the mail services. And really this means that that password is flowing in a lot of different places that you really don't need it to go. We could have the central auth server generate a session, hand it back, then instead of passing the password through, we're passing a session through the whole time. And when you come in at the end into IMAP to check your mail, then we can validate that session instead of revalidating the password again. This new central auth server is going to greatly improve the maintainability of our product. For one thing, it's all being designed in an object-oriented fashion. This isn't 90s Perl code. This is modern Perl code following modern design patterns. Each module is going to be testable, and the overall system is going to be testable. Making sure that we can validate that every bit of the code is functioning as expected is a very important project goal. By centralizing all the authentication logic, it's going to make it much easier to maintain all the services that depend upon authentication. Really, if you were to look at CPServD code right now, you would find that about 15% of it is pretty much generic authentication logic. That code does not need to be in CPServD. It needs to be in one spot where all the different services can use it. In fact, the sheer bulk of code that's required to do things like override logins is why many services don't do override logins or do them incorrectly. So centralizing that is going to make it much easier to add features to the auth system and to maintain the current features of it. The central auth server is also going to be isolated from the services that require authentication. The way they're mixed together right now, if we go in and we fix a problem, let's say in CPServD's authentication, then we have to worry about that fix bleeding over as side effects into unrelated code, because it's all mixed together. With the central authentication server concept, you're going to have the auth server cleanly separated from the authenticating service, and you only have to worry about that one socket tunnel that they're communicating over. You don't want that to change. But inside the authentication server itself, we can fix problems and not worry about them bleeding out. So that covers the overall design, but I haven't mentioned much of the pluggable aspect of the pluggable authentication framework. And really, when our customers approached us, and this was a project that began in response to customer demand, they didn't really express concerns about performance or centralized caching or any of the other things I've already touched on. What they really wanted was the ability to hook our services that require authentication into their centralized authentication servers. Their LDAP servers, their Radius servers, MySQL servers that contain all the authentication credentials. That's what customers really wanted. In addition, some customers wanted to be able to write custom code that sat at that privileged spot that CP Hulk currently does. Right now you have no good way of inserting your own code at that spot. Really, the overall design of the cPanel authentication server is geared towards this sort of extensibility. First of all, you have listener modules. These are modules that are going to speak different protocols. They'll watch a socket and be able to translate the protocol that's used to communicate over that socket into something generic that the authentication server can understand. An example of this would be you'd have a Dovecot listener or a Courier listener. You're really only going to need to write your own listener module if you have an existing service that can already authenticate over a socket. If you're writing a new service, you'd probably want to start with a more generic cPanel provided module that's already going to talk to its own socket for you and provide you with a functional interface into that. The next type of modules are service modules. These are going to encapsulate the quirks that each particular service has. As the example I gave earlier was FTP quotas versus mail quotas. A service module is the right place to make that distinction. So if you have your own custom service, you may want to write service modules that encapsulate little quirks that the generic authentication system can't handle. Auth modules are probably the most important. These are going to be the modules that handle actual authentication. For example, validating an account is a system account, or validating an account is a virtual account. These are, like with the standard cPanel setup, these are going to still use hash passwords, session files, and so on. If you wanted to hook in LDAP or Radius, these would be the places to do it. It's an area that needs a lot of focus to make sure that we get this set up correctly for people with high-end systems already set up that they want to integrate with. Check modules are probably going to be the easiest to implement. These are going to be the generic sort of CP-Hulk style interface. You'll be able to block an authentication attempt before it's validated and after it's validated, or to get informed of the fact that someone tried to log in and failed to do so. It's very important that you can block something before they log in, before you even try to authenticate their credentials, because without that, people can do timing attacks even after they're blocked. They can see how long it takes for you to deny their login attempt and guess which accounts were actually correct on that basis. Cache modules are definitely going to be central to the system. We're not sure yet whether we're going to allow customers to provide their own cache modules. If you were hooking in your own auth system, it might make some sense for you to also have a cache module that manages stored credentials for that authentication system. It kind of remains to be seen exactly how that'll work. For our purposes, though, the cache module is going to be absolutely central to making the performance something everyone can accept. And tying it all together, we're going to have service configuration files. Even if you can't go in and write your own auth module or check module, service module, listener module, the service configuration files are going to specify which modules apply to which services. So you can make some really simple customizations that presently are very difficult to accomplish just by editing these files, or hopefully we can provide interfaces to make it 1 or 2 clicks to have that happen. An example would be if you wanted to disable CP-Hulk for FTP only, but leave it enabled for everything else. Or let's say you wanted to disable virtual account logins for IMAP or SMTP. You really couldn't do that with the current design, but with this configuration file, you'll be able to easily accomplish that. So that's really the core of the pluggable authentication framework. As I mentioned at the beginning, there are some items that have been thrown in with this project. They touch on the same areas. They're not really fundamental to the overall project, but it is good to get these corrected if possible at the same time. The first is HTTP digest authentication. We've tried to correct this in the past. It's a very complicated problem to solve. It's definitely still needed. Certain web dev clients aren't going to provide HTTP login credentials. They want to send you digest instead. And PCI compliance in certain scenarios requires HTTP digest instead of normal HTTP logins. It's obviously still a very difficult problem to solve. What we really need is access to all of the plain text passwords on the systems to rehash them again in the digest format, and we don't have access to it. They're just not stored anywhere. With the central authentication server, it will be slightly easier to try this again, because every service is going to go through this one code path. We don't have to hook in caching the passwords as they come in into each and every service. We just put it in that one spot. We can also authenticate your connection, let you go on and access your service, and the auth server can digest it behind the scenes after the fact without slowing down your incoming connections. So it will be a little easier to approach it again. Another thing that's been thrown in is the virtual accounts. I already mentioned how the virtual accounts work and that they're pretty disconnected currently. I would really like to see that cleaned up. It'll make the auth server a whole lot easier to implement if we can accomplish this. What I really want to see is a virtual account being a real single account entity. You know, user@domain.com is a single account, and that user@domain.com has access to multiple services. You could have, you know, user@domain.com, I turn on IMAP, I turn on FTP, I turn on, you know, webmail, I turn on WebDAV, and so on. Or I can disable them, any combination. But it should be really a single account entity. The real problem with this is synchronization. You know, with the present system, virtual accounts are divided up by service. They're kind of balkanized. So how do I know that, you know, user@domain.com, the IMAP account, is the same entity as user@domain.com, the WebDAV account? You know, there's really no good way of knowing that at present. And so do we want to keep them balkanized, or do we want to join them together? You know, overcoming that hurdle is going to be pretty complicated. But on the other hand, the long-range benefits of fixing virtual accounts, of making them a true first-class concept, are really very nice. I mean, for instance, in the short term, we can get all of the different services synchronized, but in the long range, we could provide a virtual account with the same sort of limited access to the cPanel interface as a reseller gets to the WHM interface. You know, it's definitely possible that we could accomplish that sort of thing, or give virtual accounts, you know, more finite control over add-on domains. You know, there are definitely great possibilities there. Another item that's kind of been thrown into it is improving the service integration with various services. First, right now, when you create an add-on, we still prompt you to create an FTP account. People, you know, pretty much across the board have access to FTP clients and they understand how they work. FTP obviously is a bad protocol for people to be using. It is 2010, as I mentioned, and it would be nice if they were using SFTP. Really, this is not as pressing of a problem as it used to be because you could use WebDAV instead, and pretty much across the board, all the operating systems support WebDAV. It's just a matter of pushing it on your users to adopt it instead of FTP. But SFTP virtual accounts would be a killer feature if we could make that happen. IP logging and banning for all the services. This actually is pretty far along. We have a lot of the problematic services that had poor integration before. They do have much better integration now. And of course, full auth integration. The core services, this is a readily reachable target. For some of the other items like Mailman, MySQL, these are really difficult ones to integrate with more fully than we already are. It is a target we would like to achieve, though. So this is the end of the talk. Now, as I mentioned at the beginning, this is very much a work in progress, you know, and we definitely would like your feedback on how we can make this system work, how we can make it better. So if you could ask yourself, you know, some simple questions, you know, maybe just send the answers to me, or think about this talk in this context. First, what did we miss here? You know, I laid out the overall framework of how the system is going to work, but is there an area that immediately springs to mind that it's just totally skipped over here? It's very possible. What sounds way too complicated about the current system? We want this to be a system that's easy to understand, you know, and easy to extend, easy to work with. What sort of examples of documentation would you like to see? I mean, I'm a programmer. I look at the Perl code for the documentation, you know, but other people that are building on top of it, you probably don't want to sit there and read my nasty Perl code. You want to be able to open up some documentation and see exactly what it looks like. So what sort of examples are you wanting? And lastly, what sort of customizations do you see yourself making on it? I mentioned a few that we kind of know people are targeting, but maybe after seeing the overall system, you could see going in some other directions. Let us know what you plan to build on it, and we can make sure those interfaces are spot on the first time, you know, and you don't have to wait until 3 iterations down the road where it's stabilized to build anything meaningful on top of it. So again, my name is John Lightsey. My email address, jd@cpanel.net. So thank you very much for watching.